Hello everybody, this is Tahir here from Oderberg Permaculture Farm, and today we're going to take a look at gabian groins. So gabian groins are a form of river training infrastructure. River training is basically applying specific infrastructures into the flow course of a river to alter that flow course in one way or another to achieve a specific desired result. And with gabian groins, we are going to be looking at how to prevent rivers from washing away valuable agricultural land. So when we're looking at rivers flowing through the landscape, we can detect a variety of patterns, simple patterns that all rivers, wherever they are, follow. And one of those patterns is a snaking pattern or a curving pattern through the landscape called meandering. And this is a pattern all rivers follow generally. There are exceptions where a river will flow straight, and that's normally where the geology of the riverbank on either side is exactly the same, and it doesn't continue for very long before the river will start curving. And that curving pattern generally is caused by the river flow hitting a hard layer of rock that it can't eat into, which deflects the river. So the river will flow, hit the hard rock on the edge, and then it will be deflected in a different direction where it will hit softer material, and it will eat into that softer material until it hits something more resistant, and then it will be deflected back again. Its course will be changed once more until it hits more resistant material, and so on and so forth, and it will meander its way through the landscape. So that is one cause of this pattern. The other is the actual flow dynamics of a river itself. So when a river is flowing, in the center of the river you have the most force, and there's going to be what we call a vortex action, where we have a drilling effect. So the river in the middle will be drilling its way down the river course, vortexing along. But on the edges of the river we have what we call the eddying effect, and so that's basically where the force of the flow is less and the vortex action is more lateral. So it's a vortex action that spreads out laterally or horizontally, and what you tend to find happening there is deposition, where there's less force and energy. The silt load in the river will deposit and build up, while in the center of the river the river will be cutting away and eroding and drilling, and the force is forward rather than lateral. And so what this results in is what we call a relationship between an undercut slope, which is what we're seeing here, and a slip-off slope, which is what we're seeing here. All right, now what is the difference? Okay, so when a river comes flowing down its course, okay, and it bends or curves like it does here, because the force of the river hits a immovable object or a slightly more resilient material, a resilient clay, soil or rock, the river then gets deflected away, and so where it hits, it tends to scour and cut and eat. There's a lot of force moving into that particular area, And if the material isn't hard, it will just continue eating and eating and eating into the material. Like we see here, we've got a shale bank, and you can see over time the river is slowly but surely undercutting this bank. And we've had a recent flood flow in the river, and you can see the effects of that flood flow have caused a collapse here. So you can see the debris fallen on the ground, and it's collapsed from up there. And this process will continue over a geological time scale, and it'll eventually eat this bank away entirely. Okay, so the force of the river is concentrated on this particular bank, and we call it the undercut slope. And so the river is actually busy eating this away. But on the opposite side, the river's doing the opposite. It's depositing. Okay, so the force is now less on this side, and so here we have deposition, and we call this the slip-off slope. It's gentle and it's growing. So as this gets undercut and eaten away, this bank of the river starts to grow out into the course as the course slowly grows into this bank, and we get a curve or a bend in the river. Now, the slip-off slope tends to be a nice, rich, deep silt, and it's ideal for agricultural purposes. And then you can see here we have some production land on this gentle slip-off slope, while on the undercut slope here, it's very steep and hard and exposed, and in many cases unstable and not ideal for agricultural purposes. So this natural phenomena is entirely normal, and it happens in all rivers, and there's generally, we don't have to do anything about it unless we have a situation where we've got valuable production land above on the undercut slope that we're losing. And so this is where the infrastructure of Gabion groins becomes really important. Came through here. Yeah. Pumping through here. Alright, so we're just going to, before we get into any detail, we're just going to take an overview look of this particular river pattern as it flows through our farm. And you know, like many of these dryland environments, your farm land is always along your river courses, because that's where your moisture is, your deep soils. While, you know, once you get out of the valleys, you start to get into your rocky slopes, and it actually becomes very difficult to do any form of plant production. So, you know, we really like to make use of these deep silt fields along the edge of the river. You know, so these silt fields we're looking at are actually created by this process of deposition on the slip-off slope of the river, which is the polar opposite to the undercut process, which is happening. You can see it on the undercut side of the river. So where the one's undercutting, the other one's depositing, because the river's moving slowly but surely in the direction of the undercut. So that's a pattern. It's a part of the duality of life, where, you know, you're always going to find polar opposites existing in any context, and here you have it. So the river enters the production area, it flows straight for a short while, and then you can see it starts to undercut, and it's eating into the side of the hill. It's not ideal for agriculture, but on this side you'll see there's a slip-off slope, thicker, deeper soils, and we're in the process of developing production lands there. And then the river's deflected by the rocky bank as it gets into the side of the hill, and it hits the bedrock, and it comes this side, and again it hits the rocky underlying strata of the slope, and it gets deflected. And so you have this meandering pattern. So on the slip-off side, we've got these beautiful terraces, which we've got our agricultural systems on. In this case, it's an agroforestry system. And on this side, the undercut, we've got zone 5. But we have an issue in the sense that some of these terraces here form part of the undercut slope, and you can see, and every time it floods, that force of water that's undercutting is actually eating into our production land. And it's very common, and I see it all over the region. And often after big floods, I've noticed on some of the surrounding farms, they lose their orchards and vineyards that are along the edges of the river where the river's undercutting. And so how do we deal with this? We're going to go and have a look in more detail, because in these particular contexts is where you apply what we call Gabion groins. So it's a beautiful late autumn day here at Ouderberg. We're on the cusp of winter, and with winter are going to come our big winter storms, many of which will bring flood scale rains. And at this point in time our riverbed is dry, but it's not going to stay like that. And when it does flood, the water in this river can actually get significantly powerful, and it can really get right up, right up to where the bank gets steep, and it can flow across the slip-off slope here with some strength. You'll see debris here as an indicator of where the river flow can get to, and it's always an indicator of the strength and height of your flood water. If you are in an area where you haven't had time to observe the river flowing in all contexts, you can generally see by the deposition of sticks and rocks the height it will get to. So here we've got a very gentle undercut happening and a gentle slip off as the river flows along, and on the right side I've got some production land starting. So I've got olive based agroforestry system sitting just up there with grazing in between. And then as the river gets to this particular point here, it starts to bend quite steeply, and the strength of its drilling or undercutting power suddenly gets much more effective as compared to up here, where you can see either side of the river you've got nice established vegetation, the slopes are stable, and vegetation is always your best form of riverbank stabilization. Riparian vegetation is very important to leave it alone if it's established and not disturb it, and if it is disturbed, to encourage its recovery. And you can do that using productive species in many contexts. So the river comes through here, and this beautiful big rose bush here protects the slope, but as it gets to this particular point here, it encounters deep silts with no fundamental bedrock underneath it. It becomes soft, and the process of undercutting or eating into this riverine terrace begins. And on top is my olive system, and when we got here I noticed every flood event we were losing more and more of this valuable land. So I thought about it and did some research, and I came up with this Gabion groin system. I've noticed that it had been used strategically at different places around the world for the same purpose, and it is the cheapest, most effective way of preventing the undercutting process from happening. And what one actually is doing here, it really is simple, is that we are placing at regular intervals gabion baskets. Okay, you can see, yeah, they're regularly spaced. Now these gabion baskets have to be really sturdy and large. So in this instance they are 1.5 meter long by 1 meter high by 1 meter wide boxes, and when they're filled with rock they're very heavy, and the river is not going to move them. Even though at times when this river's really pumping, the water can be over the top of the gabion baskets. And they're called groins because what we do, instead of protecting the bank by lining the bank with gabions, which would, for one, be a hell of a lot of work, require a huge amount of rocks to be moved and very expensive, we place intermittent gabions at right angles to the flow course of the river. These boxes have to be embedded into the bank so that the water cannot erode behind them. And then what happens is, as the river, and we'll have a look at some other examples that are more clear cut and easier to see the patterning, as the river comes in, it hits these gabion baskets and it creates a back pressure. So now the water can no longer flow straight, it cannot drill. It creates a back pressure, an area of relatively still eddying water, and it has a depositional effect. Okay, so it starts to deposit, and what it does is it moves the force of energy in the center of the river over more towards the slip-off slope. It's called river training. So you training the river to flow in a slightly different course so that it is less destructive on the undercut bank where you've got valuable production land, or you might have building infrastructure or road. And after a series of floods, the depositional effect is such that the bank starts to recover and rebuild, and you can see it here. So this effect of sheer clay banks has now been softened, and you can see where the gabions have been placed. We've now got a gentle depositional slip-off slope effect happening, and there is vegetation colonization and succession happening before where there was erosion. So we've turned the situation around from being erosional to depositional, and you can see over here it's quite pronounced. The ecosystem is now well established here. It's stable. The force of the river is no longer eating into this bank. It's now moved the course over a bit, and we have recovery. And in time you'll find that as succession goes along, you'll find bushes and eventually trees colonizing this edge of the river, all because of the insertion of the gabion groins. And this bank is now stable, and the production system above it is secure. So the trick is to work out at what intervals you need to place these groins. So if you have them too far apart, you lose that effect of back pressure, and the undercutting will carry on a few meters behind the gabion. So you'll only stop the undercutting immediately around the gabion. So they need to be placed close together, at least 3 meters apart, 3 meters to 4 meters apart. And the steeper the bend in the river, actually the closer together they need to be. And so here we have placed 5 gabion baskets, and this was done about 6-7 years ago. 7 years ago. So these have been in place for 7 years, and it's stable, you can see. And then at this point the river is starting to move away now from the area I'm trying to protect, and it's shifting the force of its energy into the opposite bank, and you can see the undercut there. And I have a fortunate situation where I've actually got a natural gabion here in the form of a large rock. Now this rock just illustrates a point, is that having the gabion at an angle like this rock's at is not ideal, because you don't have that same back pressure that creates deposition behind it. It has to be perpendicular to the river flow. And so what this rock's achieved is it's prevented the river eating away in that direction. And it's created a protected area behind it, and you can see vegetative succession happening. Now this rock's obviously been here a lot longer than these gabions have, and so you can see the succession is more pronounced on that side, but behind it, it hasn't really achieved the desired result of building up a slip-off slope. It's just prevented the undercutting of that particular area, which is why the gabion groins need to be put in at a right angle to the bank to have this slip-off slope creation. And here it is. You can see there's the gabion. That's how much build-up has happened over time since we put these in. So here I am on top of the undercut slope, walking above the gabion groin system, and you can just see how unstable this situation is and how close I am to losing these olive trees to flooding, and it could actually just take one flood event to cut right in here. And so these gabion groins, by their insertion into the river flow dynamic, have resulted in a long-term stability to my agroforestry system over here at very little cost and no maintenance. Here you can see how close the collapse due to the force of flood water actually got to my production system. You can see it's right on the fence edge here. I mean, I didn't put this fence up, this was here before we got here, but by putting these groins in, this is now stopped, and we've got really solid recovery happening here in the form of a running grass. And in time I'm actually going to plant a tree here just to increase the stability. So it's an area that you can then work on, and there'll be a lot of water stored in the ground between these two gabion groins here. So you have a reserve of water sitting in there that will enable growth by virtue of stored water in the soil that would not have been there without the gabion groins. And so you've created a micro environment for the growth of a productive tree or a native tree that would not have been possible otherwise. Okay, so we're just going to have a look at gabions themselves. Okay, so here we've got a whole series of gabions, different sizes. None of these are actually really appropriate for the type of river training we're discussing in this video, which is gabion groins. They're too small. They're not actually heavy enough to, in my opinion, unless the river you're dealing with is small and not particularly powerful, to function as groins. So these are 50 centimeters high, 50 centimeters wide, 2 meters long, and we use them for building sand dams, which you can find out more about in our sand dam video. So you can just check the description below for that. And then there is a larger one here, a 1 meter wide, 50 centimeter high, 2 meter long, which in some instances could be used if you have to dig the gabion into the bank quite a lot. But again, it's just a bit too low and the river's going to go over the top of it and cut away above. So I think the minimum height should be 1 meter. But there's nothing stopping you from building your own gabions, and we've done quite a lot of that using old fencing wire, such as this, we call Bonox fencing. And the only challenge is the gaps in the fencing are quite wide, and so you're limited to using really big rocks, heavy rocks. So that is the one downside of it. But the wire's got to be thick. Otherwise it just rusts away, or it actually gets smashed by rocks moving down the river. And so this type of fencing wire you can see behind here is not appropriate. It's not thick enough. So yeah, you want this at least. Okay, so here we have another great example of the application of gabion groins into the stream course to alter the flow of the river, to train the river. So here we have a really large undercut river slope, quite close to the core of our homestead zone, and the river comes through here with significant power. Rampaging. Yeah. And we have some building infrastructure at the top of the slope. Not something that we ourselves constructed. It was here already. I don't think I would have put this particular building in this place. But within these narrow dryland river valleys, you don't have a lot of opportunity to practice agriculture and to place buildings far away from the river because of the steep nature of the river valley itself. So it's very important to determine your 100-year flood line, and in our case it's quite easy because some of these buildings are over 200 years old, and they've survived 200 years of flooding. So it tells a story. It says that firstly there is actually a limit to this amount of water that this river has flowing through it. It is determined by the catchment area, the area that your river is receiving runoff from. Okay, that'll be from the edge of the watershed of this particular river. Okay, so there's a limit to that, and it's also limited by the vegetation that grows within your catchment area. So these dryland areas don't have dense vegetation, and so they've got a high runoff. It generally comes in big surges with a lot of silt. And that silt, and in many cases small rocks or even boulders, has a significant corrosive impact, not only in the middle of the stream, but on these undercutting slopes like this. So this was, for me, a huge red flag, and it was the first place that we put these gabions in because I did not want to lose this building. And so we started with 3 gabions here, here. The other one is basically completely buried now. You can't even see it. Such is the effectiveness of these systems, but it's here, it's there. Okay, let's see if we can get round to it here and show you. Oh, here it is. There's its edge. All right, so that where I'm standing now, all right, was the floor of the river. Okay, so it was like this, and through that, the application of the groin, it pushed the river this way, and it created a depositional zone behind it. You can see all of that. There's the original undercut over there, has been recovered. So I'd say this is about 8 years old, and we've got trees now that have grown behind the gabion. And then we put another one here, so 4 meters further on, and it has virtually been buried, okay, by silt deposited behind this one and behind this one. And so what we did is we put another one more recently, about 2 years ago, on top of it, to stop the river in severe floods cutting the bank there. And you can see how that is now built up, and we've got really solid vegetation where I'm standing now. It's built up significantly. And then last year we added a 2 meter by 50 by 50 on top of this 2 meter by 1 by 1 gabion, because the water was going over the top and eating into the bank over there. And yeah, so it creates a wall, a back pressure and deposition, and it'll stop, and it has stopped that undercutting. All right, and so this whole area here has now become stable. I don't have to worry about it or lose any sleep over it if it floods in the night. lying there thinking, geez, what's it going to look like tomorrow morning? But since then, the undercutting process has continued on this section of bank here. And you can see the slip off over here. Now, a long time ago, now this is probably going back 150 years, the farmers then created their own gabian groin, well, their own groin here, just by packing rock. Okay, so the river was coming straight through here, and so what they did was they created a groin by packing heavy rock, and that created a depositional zone behind it, and it had the effect of moving the river over this way, which I don't think was particularly wise. And you know, over the previous year, which was the wettest year in recorded history here, we had the river really cut into this bank. And if you look, there's some buildings over there, and the river is basically going to eat its way across towards those buildings. And so I've started a process of implementing gabion groins here, and these are very good examples of what I want to show, because the pattern in the river is very clear. I still need to put another one here, which we're going to do once it rains significantly and the ground gets soft enough to dig a gabion into, like we've done here. So you can see with this groin, okay, this is a 2 meter by 1 meter high by 1 meter wide, and we embedded it in the bank, and you can see the pattern. The river has now formed as a result. You can see the river comes flowing along. It's been deflected by those groins. It's cutting in here, and the reason we actually started here is because the material on this undercut slope is softer here, while over there's more gravel, more stone, and so it's a little bit more resistant to erosion, and so it was taking longer to get in there, but here it was going quite quickly. And if you notice the contour, the bank goes in there suddenly. So what's happened is the river has hit this groin, backed up. Now, since this pattern has arisen, the river hasn't come down in significant force, not enough force to deposit, and you can see in this clip what I'm talking about. Last time the water was coming over the top of this gabion, been nicely diverted. You can see how still it is here in front of this gabion groin, and the water's getting diverted past now, and then building up again behind this one here, which is creating a depositional zone. We'll take a look at it from the side here, and you can see immediately there's a depositional zone behind the groin as the water gets diverted around, and you can see there's already debris catching behind it, and the strength of the river is no longer eroding away at this bank anymore. It deposits. Very nice. I think in the longer run we'll probably put another one like this over here. The reason we didn't do it is because the ground here has got quite a lot of rock in, wasn't being eaten away as fast as that. But now you can see the change in trajectory of the river. So here it's very much against the bank, and then after the groin it's heading down the middle of the river, which is exactly what it's supposed to do. That's what the design is for. So we've got nice stability here. So what it has done, which is very useful for the purposes of this training video, is that it stopped flowing in that direction and it got diverted around, and you can see the pattern the river has taken as a result of this groin. And this is the pattern that groins achieve in rivers. But what's interesting is that on this side we've already started to have deposition by virtue of this groin. Now, this is not a classic example. This is a arrangement that I've made that is a specific response to a context. So what was happening here was the water was going through here towards that building, and so we just followed the pattern of the river bank. So we've got a road that comes down here at an angle, and we put this gabion groin, which is a 50 by 50 by 2, to stop the river going through there. But we knew that because it was at an angle, it wouldn't have this effect of creating a high pressure zone behind it, a backing up of the river. So underneath it we put a 50 by 2 by 1 meter gabion perpendicular to the river. We put it lengthwise because we didn't want the gabion to extend too far out into the river, because that can create its own problems. It can push the river too far in the opposite direction. I wanted the river to go straight down over the wall of the sand dam there. And so you can see that the river's responded. You can see how the water's gone around the gabion here, and you can see how the water's come around this gabion here, and we've got a deposition happening behind. So when we get a significant amount of water coming through here in a big flood, the gap between these two gabions is going to silt up, and it's definitely going to silt up behind here, probably to round about here, which is where we're going to put the next gabion. And then, you know, what we'll do eventually is put another one in here, and then this entire slope area will be secure. So it's a process, it's a step-by-step process. You know, it's very difficult to get it all in at once, because often you just can't observe everything in one go. It takes time to actually understand the river flow dynamics of your area. But it's not something that you would leave either, because you know that this pattern is ongoing and it will eventually have the effect that you don't want, of eating away valuable land on the undercut. If, for example, there was some rock further back in here, I wouldn't bother, you know, the large boulders or a shelf of rock sitting under there, but there isn't. It's quite soft till quite far back, and I don't want the river to cut around the back at all. And so it's a relatively small investment. It's a lot of sweat work. It's heavy going. You know, you need a tractor and a trailer to get the rock in, because there's very seldom enough rock immediately around the gabions for you to fill the gabions up. And if you're making your own gabions, the cost is a lot less, but the long-term effect is invaluable, and it will last, in my mind, forever, because by the time these gabions rust away, and that'll be probably like 20 years down the line, they're going to be under silt and with established vegetation belt and trees that will take over from them. So a very simple technology in river training. It's an infrastructure that anybody can make through very careful observation, and by using the correct principles. Gabion groins 90 degrees to the river flow, okay, perpendicular to the bank. Embed them a little bit into the bank so that the water can't go behind them. Place rocks behind them as well, just to make doubly sure, in the case of a really big flood, that there's no opportunity for the water to get around. And there you have it. And then as the river starts to build up, you may need to add another layer on top, you may not. So over here I certainly won't, because the river flow is not going to, there's no bank I need to protect behind it like I did over there. And so it's a creative response to the dynamic of river flow patterns that allows you to achieve a few things at once. Stability of the river banks, creating an environment to put a riparian edge on that could be productive in a wetter environment. It protects the land behind the Gabion groin system as well. And it obviously provides a lot of niche for small wildlife, insects, rodents. It's a trap for seed and river deposition, which can be used as mulch in some circumstances. And it allows you long-term peace of mind because you know that your infrastructures and lands on the inside of the undercut slope are now stable. Okay, so there it is. Very simple, straightforward system. Applied correctly, highly effective for very low input. Thanks for watching.